One of the most important topics to understand in Ethereum is gas and how it relates to the transaction fee structure in Ethereum. But why should there be any transaction fee at all? The answer is more to do with network security than economics. Web applications and networks are often subjected to denial of service or DOS attacks. DOS attacks involve flooding the web application or network with requests which consume all the computational resources of the network and make the network unavailable for intended users. One way to protect the network from DOS attacks is setting benchmarks for computational resource usage and introducing a transaction fee linked with the use of computational resource. In the case of Ethereum, this benchmark for computational resource usage is called gas. Gas refers to the unit that measures the amount of computational effort required to execute specific operations on Ethereum network. One computational step costs 1 gas, but some applications cost higher amounts of gas as they may involve more computationally expensive operations or require network storage. The fee system intends to require an attacker to pay proportionally for every resource that the attacker is consuming. These resources include computational resources, bandwidth, and storage. Hence, any transaction that leads to the network consuming greater amount of any of these resources, that is computational resources or storage or bandwidth, must have a gas fee roughly proportional to the increment. Each contract in Ethereum needs to mention a gas limit. The gas limit signifies the maximum amount of gas that the user is willing to spend for the transaction. Basically, gas limit means the amount of computational resources this smart contract is going to consume. If the actual gas required by the transaction is lower than the gas limit, the remaining gas is returned to the user. But if the actual gas required for the transaction is higher than the gas limit, the transaction fails with an out of gas error. The gas limit will be completely burnt and the user will not get it back. The gas fee model also protects the Ethereum network from congestion due to unintended infinite loops. The loop will end when it is out of gas.